Hello, my name is Mudvari from the ImagineerBots group, and I am in charge of the robot, the QueueCue. This is the circuit. Please excuse my cabling. I try to make it as organized as possible. I'm also going to flip the LCD screen for the purposes of this video. I only turn it around for the sake of cabling, but I'm going to turn it in and then I'm going to turn it around just for the video. I'm going to edit that. For the circuit, we got the Arduino, of course. We got two PIR sensors, or PIR. I don't know how to pronounce it really. This is the PIR in and this is the PIR out. DC motor for the fan. 9-volt battery, an LCD with a potentiometer for the contrast, and a resistor. We got an L293D, and obviously the breadboard for cable, and the servo for swaying the fan. I forgot the servo. And now for the code. We got our libraries, of course, our pins for the LCD and motors. And then these would be our parameters. This, of course, would be assimilated to the individual needs of the ride. For the purposes of this video, I put, for example, I'm setting 10 seconds just because I didn't want this video to be too long. But this will probably obviously change. Here we define the states that we're going to be on. We got 3 states: idle, stop, and go. We also set up the people count. Here we got some functions to turn the fan on and off. And we set the different text the LCD will display in each state and the conditions. So this is really where the magic happens. We got obviously 2 peers, or PIRs, I don't know how to pronounce it. We got peer 1 and peer 2. And we got it set up so that when peer 1 fires, which is peer in, when peer in fires, it adds 1 person to the count. If it's the first person, it'll turn on the fan. Here, let me extend this. It'll turn on the fan and the servo. But if it's not the first person, it just adjusts the ETA. And when peer out fires, we subtract 1 from the count, and we display stop and adjust the ETA. But until the line clears or the queue clears and the count hits 0, and then in that case we turn off the motors and display goes to the idle screen, and this is essentially how the QueueCue paces the line. So this is the essential part. Then we got this to change the state from stop to go after 10 seconds. You'll see it on the simulation. This is for the commands for the fan and the servo. And then finally, we got the void setup, of course, and the loop, which is basically just the checklist repeating what we already defined over here. And then now for the good part. Let's see it. Start the simulation. Here we go. So we got the screen here. We got the serial motor here. This is waiting for the peer in. So we got the peer in and the peer out, right? Let's adjust it. And then as you can see, the fan is off because there's no one. We got no one on the count, right? I'll go back here. And then, so whenever it fires, it adds 10 seconds to the ETA. For every person, it adds 10 seconds. And then that's basically 1 person coming into the line. Then we're on another person, but it says go. So another person can go. And then, so the peer out, when the person actually leaves, the peer out fires. And then it goes back to stop and it reduces the count. Let's say 1 person, more person comes in, another person comes in, another person comes in, and it's still in stop, and it says go. So this person goes out. And the ETA goes adjusting depending on how many people are on the queue. So we got the wait time is approximately 60 seconds. It's 10 seconds per person, and then it's go. So this person goes, it goes back to stop. So the next person stop. And as soon as a person comes into the line, obviously the servo is swaying for the fan to be moving, and the fan is on. And then it says go again. So it says go again. So let's go. And then back to 40 seconds. It reduces to 10 seconds. And then we go. We're waiting. Let's say another person comes in. Another person goes. Okay, you can go. You can go. And then I'm just going to go ahead and go. Even though it says stop, I'm just going to go ahead and go to reduce the time a little bit. I'll stop it here. So let's wait for the go. And then so that this last person can get out of the line. We're still in stop. And then it displays go. So go out the line. The count goes back to 0. And the idle screen goes back. Also, the monitor turns off and the servo stops swaying. And that is essentially what the circuit does and the code. Thanks so much.